Okay, so here's part F and G. It says the question before part F and G start. Question says the curvature at any point x comma y on a graph is defined as k equals 2, and then they have the absolute value of the second derivative divided by 1 plus 1 plus the first derivative squared, all raised to the power of 3 over 2. So it's quite a complicated formula. It's definitely something that's not within the scope of MathHL. What I mean by that is we don't explicitly talk about curvature and its definition, but this is an example in MathHL where they're providing you with some new piece of information and they're asking you to reason about the new piece of information. So I know it can be a little bit scary to see new math on an assessment, but just stay calm and just kind of work through the problem based off of the defining features that they give you. So first thing, they say find the value of the curvature of the graph of f at the local maximum point. So what they're saying here is, because this curvature value is defined based off of these derivatives, but you need to evaluate these derivatives at specific values before you can find the curvature at a specific point. Okay, so you can think of curvature as a function of both the x and y coordinate, and then once you supply an x and y coordinate, you'll get like a value back. Okay, so here's our x, so I have it up here, and here's our y, and we can use that to determine the curvature. So when x is equal to 3/4 of a pi and y is equal to about 7 point, so this is approximate, okay, about 7.46, k is going to be equal to, and what we do is we take these values and we plug them into the corresponding derivatives. Okay, so maybe I'll do that on the side. So when x is equal to 3/4 of a pi and y is approximately equal to 7.46, our second derivative of y with respect to x is approximately equal to, and then you would go ahead and you'd calculate that. And then you do the exact same thing for the first derivative. Okay, so you would say, oh, when x is equal to 3/4, what's the value for the first derivative? Now in this case, actually, we know what the value is. So if we go back at 3/4 of a pi, when x is 3/4 of a pi, we have a stationary point. So the slope of the tangent here is going to be 0. So that's going to be 0. I don't really know what this value is going to be. Okay, so this is an instance where I'm just going to use a calculator and figure it out. And it's going to be negative, but I'm not sure what the value is going to be. Okay, so after I plug this into a calculator to 3 significant figures, I'm getting negative 14.9. I'm going to take this value, and I'm going to plug it into my curvature formula. Okay, so the curvature formula is take the absolute value of whatever I got back from the second derivative, that was negative 14.9, and then divide that by 1 plus whatever I got back from the first derivative squared, and then raise that to the power of 3 over 2. Okay, so that's going to be roughly 14.9. Okay, now for part G, it's kind of similar, but they're saying find the value of the curvature at x equals pi over 2, but also comment on its meaning with respect to the shape of the graph. Okay, so for part G, I'm going to first jot down what the values are. So when x is equal to pi over 2, what I want to know is what dy by dx is, and also what d squared y dx squared is. Okay. Okay, so actually the value for the second derivative is 0, and the reason for that is pi over 2 is an inflection point. So if we go back here at x equals pi over 2, the concavity is changing from concave up to concave down. So because of that, we're going to have the second derivative being 0. The first derivative is positive. It's roughly 4.81. If you want, you can write it in exact form. And then what we're going to do is we're going to find the curvature at this x coordinate. So if we go back to the curvature's formula, we see that we first have to take the absolute value of the second derivative and divide that by all this. So if we look here, we can see that the second derivative here has a value of 0, and when we divide by a positive value, we're just going to get 0 back. So the curvature's value here is just 0. And what they want you to do is they want you to comment on the results. Now, like an understanding of curvature is beyond the scope of MathHL, but you can see that the value of the curvature seems to be giving us some notion of concavity, or when concavity changes. It's giving you a measure for how curvy a function is. So in this case, when we go to k equals, or when we go to x equals pi over 2, we see that when x is equal to pi over 2, we have a change in concavity. It goes from concave up to concave down. And if you kind of zoom into here, you can see that in this window here, where the curvature is 0, the graph behaves as if it were a straight line. And that's why the curvature is 0. It has no curvature at that x coordinate. And curvature here is kind of like saying it has no concavity. So here the k value is going to be 0, and that's because the graph can be approximated with a straight line. And you can see that that's not the case here, for example. Okay, so here the graph is curvy. Here it's like kind of looks like a straight line. Okay, so here we could say k is 0, and then the comment we can leave is near x equals pi over 2. The graph behaves like a line, something like that. Okay, and that's part G. That was probably one of the harder questions on this formative.